All right, we're on our last objective of Power Focus Area 4. We're going to go into a little more detail about the electromagnetic spectrum. I know we mentioned it a little bit in the last objective, but a lot more detail here. All right, there are 7 different types of EM waves. The one we've most focused on up to this point has been light, visible light, but here are the 7. Make sure all are included in your notes. I know you've heard of microwaves and radio waves, possibly infrared and ultraviolet. X-rays too. Gamma rays may be the one you haven't heard of, but we'll talk a little bit about each, and we'll also show you a 3-minute video that shows you some examples of each as well and how they're used in our everyday life. So what is the electromagnetic spectrum? The picture there shows it. It's a representation of the spectrum, but really it's just a list that shows all the EM waves organized in order of their wavelength. So if you look down here, we have pretty big wavelengths on the left side here, starting with radio waves, which have the biggest. And as we go all the way down to the right in this EM spectrum, the wavelengths get a lot shorter. So we're just going from left to right in increasing order of frequency, decreasing order of wavelength. This is super important. Super important. This slide is the most important slide of this slideshow. EM waves that have long wavelengths on this side, remember, really long here, and low frequency don't have much energy. And it makes sense. Radio waves are hitting you right now. They're hitting us all day, every day. It doesn't do any kind of damage. It doesn't hurt us. We don't feel it. It doesn't cause cancer, nothing. You can stand next to your microwave while it's cooking your food. Same thing. It's low energy. It's not going to do much. On the other side of the spectrum over here, we have short wavelengths with high frequency and high energy. Lots of energy. These are deadly. Gamma rays can be deadly. These are actually given off when stars explode, so tons of energy, very harmful. X-rays are actually harmful too. They can cause cancer with prolonged exposure. That's why the person that takes your X-rays, if you're having a broken bone checked out, they don't even stay in the same room as you, so they're not exposed. And if you're getting an X-ray like on your arm, they put this big heavy lead vest over your body, so none of your important organs like your lung and heart, so they don't get hit by X-rays because they know it can cause cancer. So we said before, all EM waves travel at the same speed, but since they have different wavelengths and frequencies and energy, they can be used for different things. And the video will show us more about that. When we just focus in on the visible light, because that's all we can see right in the middle here, when we just focus in on the visible light, red light, notice, it's on the left side, on the side that has bigger wavelengths and lower frequency, so they have a little bit less energy. The purple on the right side, well, it's on the shorter wavelength, higher frequency, more energetic side, so purple actually has light has more energy than red. Not enough to make a noticeable difference, but it does actually have a little bit more energy than red.
Radiation causing horrible things like cancer and warmth and food and cell phones and sunsets since the beginning of time. What are we talking about? Welcome to another edition of I Don't Think That Means What You Think It Means. Radiation. It's when energetic particles or waves move through space, and it's pretty much the best thing ever. Radiation includes visible light, which is always bouncing off of stuff and then hitting our retinas, allowing us to not stub our toes and generally enjoy the splendor of the world. It's also what plants convert into the food we eat. Infrared, or IR radiation, which is this stuff that actually warms the earth, so it's the reason that we're not all freezing to death right now. Microwaves, which not only heat up our hot pockets, but also transmit our cell phone calls. A huge amount of study into whether these microwaves cause cancer indicates that they probably do not, and the World Health Organization classifies them in the needs more study category, along with coffee and pickled vegetables. Radio waves, which carry, yes, radio signals, also 3G and Wi-Fi and all that good stuff. And then we have the extremely low and very low frequency waves, which aren't super useful but don't hurt anybody either. Unlike all of the above examples, some kinds of radiation can transfer their energy into atoms and ionize them, removing electrons, which is where the problems began. When most people think of radiation, what they're really thinking of is this radiation, which is ionizing radiation, including X-rays that can ionize atoms, but it's generally worth it to take a peek at your broken bones. Ultraviolet radiation, which is mostly non-ionizing, but can excite atoms enough to cause some unwanted reactions, like in our skin, which is why we put on UV protection in our sunblock. Gamma rays, which are pretty much the worst kinds of all the radiations because they can travel through pretty much any material and then ionize an atom right out of your DNA, leading to some pretty serious problems. Now, thus far, we've only been talking about waves, but as I said at the beginning, radiation is energetic waves or particles, so there are some forms of radiation that are actually particles with mass. These kinds of radiation are only caused by nuclear reactions. An alpha particle is a flying bit of atomic nucleus, 2 protons and 2 neutrons stuck together. They're so big and slow that they don't generally cause much damage unless you ingest something that's emitting them, so I suggest you don't do that. Beta particles are energetic electrons that are more ionizing than alpha particles, less ionizing than gamma rays, so they cause some serious damage as well. So now you know. And if your friends don't know, send this to them, because if we use the word radiation like it's evil, all of the helpful forms of radiation might get angry and go on strike, and then we would all die. Thank you for watching this episode of SciShow. I don't think that means what you think it means. If you would like to suggest future topics for this program, please leave them in the comments, or you can connect with us on Facebook or Twitter. We'll see you later. Goodbye.
All right, the most important things he said as far as our content assessment go are that microwaves carry our cell phone calls, and radio waves also do that a little bit, but they also carry things like Wi-Fi and 3 and 4G. I'm not sure about 5G that's coming out now, but I assume that as well. Infrared waves help warm the Earth. Without it, we'd be too cold on the planet to support any kind of life. So those are the big things that he mentioned that you could see on a content assessment.